When you're solving exponential equations, it's important to note that if you have two exponential expressions that are equal to each other, and the bases are the same, but the exponents are different, that means that the exponents will be equal to each other. So anytime that you are working with a exponential equation, you want to make sure that you write it so that you have each side has a base raised to a power, and you want to make sure that those bases are the same. Once you have that, then you can just set those exponents equal to each other and solve for whatever variable may be remaining in that simple equation that you have to solve. So let's just jump right in and do some examples. All right, so in this first equation, we have 5 to the 3x minus 6 power equals 125. Well, the first thing I know is that 125 can be written as 5 to a power. So I am going to keep the left-hand side as 5 to the 3x minus 6 power. And on the right, I'm going to write that as 5 to the third. As you can see, I now have both sides have a common base of 5, so I can set their exponents equal. So 3x minus 6 is equal to 3. And now all I have left to do is to solve that simple equation, that simple linear equation. So I'm add 6 to both sides. I get 3x equals 9, which gives me an answer of x equals 3. Again, as always, make sure that you plug that back in, check it to make sure that it works. And as you can see, if you plug in the 3, you would get 9 minus 6 is your power, which would be the power of 3. So 5 to the third power is 125. It does check out, so then I can put a box around my answer. So always make sure you're checking your work when you finish these problems. All right, what do you do if you can't write both sides, but if both sides aren't the same power? Notice we have an 8 and we have a 4. Then you have to ask yourself, what base do 8 and 4 have in common? And the answer is 2. Instead of writing 8 on the left-hand side, I can write that as 2 to the third power, which then I would have a power to a power. I could apply my power rule, and this would be 2 to the 3x plus 6 power. So that's how I can simplify that left-hand side. On the right-hand side, I have a base of 4. 4 I can rewrite as 2 squared, right? 2 to the second power. And then again, I can also apply the power rule. So 2 times x minus 3. So keep the base of 2. My power would be 2x minus 6. Now I have them with the same base on both sides. So you may have to get a little creative. Once your bases are the same, you can set your exponents equal to each other. So 3x plus 6 is equal to 2x minus 6. And then you can solve that linear equation. So I will get all the x's on both sides by subtracting 2x from both sides. And then I will subtract 6 from both sides to isolate the x. So I get an x value of negative 12. Again, as always, make sure you plug this back in and check. I have done that already, and it does check out, so that is my answer. All right, so anytime you are solving these exponential equations, that's the first thing you want to do. There are going to be times, though, that you can't have a common base, so on both sides. So if that happens, you're going to have to utilize logarithms. So what you want to do is you want to isolate the exponential expression. So you have a base raised to a power equals something, and then you can change it into exponential form. And you can use, or you can take the natural log or common log of both sides of the equation and solve. So anything that you can do to help you change that exponential expression into a logarithmic expression would be fabulous. And again, there's no right or wrong way to do this, so you may see people write it different ways. So in this first example, I'll show you 2 different ways to do it. And then you can decide. You'll notice you get the same answer, so it won't matter how you solve it. Again, just show all your work. All right, so here is my equation. 5 to the x equals 134. Obviously, 134 is not 5 raised to a power. Let's do option 1. So option 1, when it comes to solving, I already have my exponential equation expression by itself, 5 to the x power. So that means I could automatically just go right into logarithmic form. So this is going to be log. It's going to be a base 5 of 134 is equal to my exponent, which is x. And then I can use my change of base formula and use any log I want. Common log, natural log, doesn't matter. I'm a big fan of the natural log just because it's faster to write. So this would be natural log of 134 divided by the natural log of 5. So there is my exact answer, natural log of 134 divided by natural log of 5. And then you can put that in your calculator and get a decimal approximation, which turns out to be 3.04. So this is your exact answer. This is your approximate answer. Both of them would be correct. Most people, instructors, software packages want the exact answer. But sometimes they may ask you to approximate to 2 decimal places or 3 decimal places or whatever the case may be. So just make sure you're following the directions. All right, now option number 2. The second option you have in solving this is what you can do is just take the log, the natural log or the common log of both sides, whichever you prefer. I am a big fan of the natural log. So I'm going to take the natural log of both sides. So I'm going to take this side, I'm going to take the natural log of that. This right-hand side, I'm going to take the natural log of that. So on the left, I have a power, so I can bring that power in front. So this is x times the natural log of 5 equals the natural log of 134. And then to get x by itself, I would just divide both sides by the natural log of 5. So I get an answer of x equals natural log of 134 divided by the natural log of 5. And notice it's exactly the same answer we got when we did it the other way. So just know that you have some options here. Just show all your work and make sure that you have not broken any of the rules. So that should help. All right, next example. All right, so in this example, we have 10 to the x power equals 8,000. Obviously, I can't write 8,000 as 10 to a power. And I've got a base 10, so using the natural log does not make any sense on this problem. I would change this. This would be a log base 10, which would turn me into, and again, you can do it either way, option 1 or option 2, like we did the last problem. I'm going to do it like option 1. So this is a log base 10, so it is a common log of 8,000 equals x. So I would just write that as log of 8,000. Anytime it's a base 10, you don't have to write the base down. We just assume. So there is my exact answer. And then if you needed to put that in your calculator, this you could just type right in your calculator, right? Press log button and then 8,000 and boom, you're done. So that would give me x is approximately 3.90. So again, there's your exact answer. That's what most people prefer. If they want you to write it in set notation, it would just be flower brackets and log 8,000. There is your exact answer. Right, and then of course you could break down that 8,000 as well. There's like 100 different ways you could write the answer. So please just listen to whatever your instructor says and follow their directions. All right, then you get to the worst kind of scenario where you've got 2 different bases on each side and both of those bases are being raised to powers. This is not difficult, but it is very time consuming. So be prepared to get some hand cramps here. All right, so this one you can't just automatically go from exponential form to logarithmic form because I have 2 bases and 2 exponents. So this one you will have to use option number 2 where you're taking the log or the natural log of both sides. And like I said, I prefer the natural log, so I'm going to do the natural log of this left-hand side and the natural log of the right-hand side. When I do that, I can utilize my power rule. So those powers, that 2x minus 1 is going to come down in front. So I'm going to have 2x minus 1 times the natural log of 3 equals x plus 1, that power comes in front, and then times the natural log of 7. Then I can utilize my distributive property. So this would be 2x times the natural log of 3 minus the natural log of 3 on the left. And on the right, I'd have x times the natural log of 7 plus the natural log of 7. All right, then I can say, okay, I have x's on both sides, and that's what I'm trying to solve for. So I'm going to move anything that has an x over here to the left. So I'm going to move that over here. And then anything that doesn't have an x, I want to move to the right-hand side. So this natural log minus natural log of 3, I need to add that to both sides. All right, so I get 2x minus x natural log of 7. Whoops, helps if I write the whole thing out, right? Let me try that again. All right, so 2x times the natural log of 3 minus x times the natural log of 7 equals the natural log of 3 plus the natural log of 7. Okay, so I have all the x's on one side. Now I notice that both of those have an x in each term. So the next thing I can do is factor out that x. So if I factor out that x, That leaves me with 2 natural log of 3 minus natural log of 7. All right, so now I can solve for x because I finally have it by itself. So all I have to do to solve this is divide both sides. But oops, that was a very interesting line. Let me erase that and try again. All right, so I'm going to divide both sides by this 2 natural log of 3 minus natural log of 7. So divide that over here as well, 2 natural log of 3 minus the natural log of 7. So that is my final answer, my exact answer. X equals the natural log of 3 plus the natural log of 7 divided by 2 times the natural log of 3 minus the natural log of 7. That is my exact answer. Notice, very time consuming. You can put that in your calculator. Be very careful if you do. Make sure that you put parentheses around your numerator and denominator when you put that in your calculator, but you should get x is approximately 12.11 when you put that in your calculator. So we have our exact answer using the natural logs, and then we have our approximate answer utilizing the calculator. Now, that to me is the worst type, not because it's hard, but because it's very time consuming and there's lots of steps and there's lots of little places you can make a mistake. So make sure you go slow when you do those problems. All right, so when you are solving these exponentials, you also might be able to put in some u substitutions, and we have done u substitutions several times throughout this course. So a lot of u substitutions can help you when you're solving. So a u substitution example would be this right here. So e to the 2x minus 4 times e to the x minus 5 equals 0. Looks very much like a quadratic. And it very much looks like a quadratic because it does have quadratic form. This is e to the x squared minus 4 times e to the x minus 5 equals 0. So if I were to make the substitution that u is e to the x, then this would look like a quadratic. It would be u squared minus 4 times u minus 5, which we can factor, right? We would get u minus 5 and u plus 1. And when we solve each of these for u, this would give me u equals 5 as an answer, and this would give me u equals negative 1 as an answer. But again, I am not trying to find u, I'm trying to find x. So now would be the time to put that substitution back in. So instead of u, let's write e to the x. So e to the x equals 5, and e to the x equals negative 1. Then we could solve those to get our x answers. So this, I'm going to change it right back into exponential form. So I get my base is e, so it's a natural log. So the natural log of 5 equals x. There's my exact answer. Fabulous. This one, if I changed it, I would get the natural log of negative 1 equals x. Now, if I try to put natural log of negative 1 in my calculator, that's not going to work because remember, every log has a domain restriction, right, of 0 to infinity. So this problem will not work, this one on this side. Not that the problem won't, but that particular answer is not valid. So it gave us an extraneous answer, but this answer is valid. So that is my only solution to this exponential problem. So notice the u substitution, once again, can help you. Make sure you're always checking your answers. Make sure that you're looking for any kind of restrictions that you might have. All of that stuff we're trying to use every tool in our toolbox at this point. So hopefully you're not forgetting anything you've learned in previous lessons. So, all right, that is solving exponential equations. Hopefully these examples have helped. Come back next time when we'll talk about how to solve logarithmic equations. See you then.